I want to start off and say that I'm not a physicist, but a lot of my talk is going to be about physics. I do engineering. What I do at my job is navigate spacecraft to make sure they don't collide with one another. So that involves physics. So we're kind of extending myself here. But if you have any questions, I'll take them afterwards. So the previous presentation was great. Good job. If that presentation talked about the rules of how to raise kids, my presentation might inspire them. And we've all had moments in our lives where we've been inspired by something. And that's how I like to approach life. I use my imagination to understand life and see like the infinite amount in something. You'll see what I'm talking about in a second. So I'm not gonna talk about string theory. I know we said that we would, but I don't even know what string theory is. But I do know that we have a brief history of our universe based on science and our place within it based on my opinion. But before I get into the presentation, I want to just say that science is going to try to understand something finite. It's going to try to define it in a finite regime. So there are going to be some things that you might disagree with, but bear with me, we're going to get there. Okay, let's see. All right, so we're going to start off with what's called the standard model in physics. And basically what that does is it explains the building blocks of matter, and it's governed by 4 fundamental forces. It was developed in the early 1970s. Tons of experiments have been done to validate it, and it's well understood, well respected in the science world. The 4 fundamental forces consist of gravitational force, which is basically the pull of one object to another. So this object, it could be much more massive. It's going to pull another object towards it. It could start orbiting it. The second force is electromagnetic force. It's an attraction between positively and negatively charged particles, just like magnets. There's a weak nuclear force. It's responsible for the transmutation of a proton into a neutron. So when 2 protons collide, the weak nuclear force can mutate the proton into a neutron. So this is just talking at the most simplest terms we can get to. The book by Stephen Hawking called A Brief History of Time, and it's like 300 pages, and I'm reading it, but there's only 2 or 3 pages in there that I understood. And that's what I'm going to show you right now. So the 4th fundamental force is strong nuclear force. It holds what are particles called quarks. Protons are made of quarks. And the strong nuclear force holds them together to form a proton and form neutrons. And together, protons and neutrons form atoms. So the strongest of these is the strong nuclear force. They're listed in weakest to strongest force. All right. So the 3 fundamental forces result from the exchange of force carrier particles. So let's briefly talk about that. The strong force, nuclear force, is carried by what's called a gluon. The electromagnetic force is carried by what's called a photon. And photon is not what you fire in Star Trek. This is a photon, is a force-carrying particle. Okay, bad joke. The weak nuclear force is carried by what are called W and Z bosons. Those are my initials. Although not yet found, the graviton should be carried by a force called it should be the carrier for a gravitational force, but it hasn't been discovered yet. But they kind of gave it a force particle without discovering it. Go figure. So on here, you'll see these are the 4 force-carrying particles. And then a proton here contains quarks. Protons and neutrons together form a nucleus. When an electron starts orbiting the nucleus, an atom is formed. So when there's one electron around a nucleus, you have a hydrogen atom. If you have 2 electrons, you have helium, so on and so forth. I think oxygen has maybe 16. All right, so the standard model includes magnetic, strong, and weak forces, but it does not include gravitational, since it's really hard to fit that into the framework of the model, but that's not really important right now, what we're going to talk about. Okay, so I'm going to talk about a brief history of time. It's not brief enough to fit on one slide, so it's going to go over 3 slides. So scientists believe, okay, there's a Big Bang. At that moment, the universe is thought to have 0 size, and it was infinitely hot. So you imagine, when I watched a TED Talk who was talking about the history of time, he turned the lights off. I was going to ask everybody to turn the lights off here, but just imagine the lights are off right now. And that would be Big Bang, because there's nothing. Okay, so 1 second after the Big Bang, the temperature fell to about 10,000 degrees Fahrenheit. That's 1,000 times hotter than the center of our sun. Energy is thought to have split into electromagnetic and gravitational forces. Remember, now we have those 4 fundamental forces, so now we're going to start talking about when they were formed. So 1 second after the Big Bang, you can turn the lights on. At this time, the universe would have contained photons, electrons, and neutrinos, and their antiparticles, together with some neutrons and protons. About 100 seconds after the Big Bang, the temperature would have fallen to 1,000 million degrees. So the Big Bang was infinitely hot. It's cooling. The cooling had to happen for these events to occur. That ultimately led to life as we know it today. So, okay, so now we're at 100 seconds, 1,000 million degrees Fahrenheit, and photons and neutrons would no longer have sufficient energy to escape the attraction of the nuclear force. So now they're going to start joining and becoming a nuclei of what's called deuterium, which contain 1 neutron, 1 proton. A deuterium nuclei would then have combined with more protons and neutrons, and then you get helium, and so on and so forth. Deuterium is a heavy hydrogen. Okay, within only a few hours later, after the Big Bang, the production of helium and other elements would have stopped, and for the next 1,000,000 years or so, the universe would just continue to expand. Eventually, while that's happening, 380,000 years later, after the Big Bang, that's twice as long as humans have been thought to live on Earth. Remember, these are things now that I'm talking about. Scientists say this, and maybe Islam doesn't agree, but we'll get to that. Once the temperature had dropped a few thousand degrees, electrons started to orbit the nuclei. That's when atoms were starting to form. 380,000 years after the Big Bang, atoms began to form. Okay? The universe would have continued to expand and cool. Remember, the temperature is going down, just from the infinitely hot. And then the expansion would slow down. There would be some areas that are more dense than the others. So those would start recollapsing into each other. So atoms are starting to collapse into each other, into certain areas of the universe. And then what's happening is some are more dense, some are less dense. So you're going to get a spinning motion. So you're going to have these clouds of helium and hydrogen atoms that are starting to swirl around because there's other dense clouds that are causing the gravity to make it spin. This is a spiraling galaxy that's being formed in about 380,000 years after the Big Bang. A galaxy is formed. So then what happens is, okay, we're at the galaxies now. All right, so these clouds, they're called solar nebulae. And what happens is all the atoms start to collide with one another, and nuclear fusion starts, and stars are born within the clouds. So imagine an amazing amount of stars just being born within these clouds that are all swirling around in the galaxies born. So, okay. So some stars in these clouds are going to get really insanely hot than others, and they're going to evolve faster. And they're going to breach what's called a supernova stage much faster than other stars. So when a supernova is the last stellar evolutionary phase of a massive star's life, when that happens, it explodes. And because those protons and neutrons are all forming atoms and more electrons are getting formed, now you're getting elements like oxygen, carbon, nitrogen, phosphorus being formed within the whole cloud. And then the supernova, what it does is it kicks them all out. And then other stars start grabbing them with gravity, and they start spinning around. And those carbon, nitrogen, oxygen atoms, they start forming together, creating planets. So planets are now revolving around stars. Okay, so we walked all the way from Big Bang. All the way from Big Bang to when planets were born. Okay. So one of these planets was called Earth, and it grew by a process called accretion, which is where you're collecting all those atoms together. And then it eventually got so hot that its core became metallic, solid metallic, and it created a magnetic field. I'm explaining to you the origin of the universe and a history of time as science understands it today. So the Earth is approximately 1/3 the age of the universe, which is 13.8 billion years. From 9.2 to 9.8 billion years, Earth was bombarded by other matter in the solar system. So there's like asteroids, comets, and everything are just bombarding it. Through this process, a part of the Earth exited and started revolving around it, and it formed the moon. So that's when the moon was formed. Mantle convection, what we call plate tectonics on Earth, which makes the mantle move. Convection, the heat causes all the plates to move on Earth, created continents. Okay? Hope I haven't lost anybody yet. We're almost there. Earth is often described to have 3 atmospheres. I know you guys hear 7, but there's 3 major ones. The first was captured by the solar nebulae. So there was helium and hydrogen. Most of that has disappeared by now. After the impact created by the moon, that created the moon, Earth released volatile gases into the atmosphere. So these are called the greenhouse gases. Kind of probably looked like Venus back then. But it was really poor in oxygen. So at this moment, there were oceans. There were oceans on the Earth, and there were primitive forms of life, what we like to call DNA, began to form and eventually reproduce themselves through trial and error, which is better known as evolution. These primitive forms of life inhaled hydrogen sulfide and exhaled oxygen. They exhaled so much oxygen that it created a 3rd atmosphere as we know it today. So through all these atmospheric developments, we got 3 atmospheres, we got oxygen. It allowed more sophisticated organisms to grow through self-replication and metabolism. The building blocks for humans were formed. Okay, so I just walked you through Big Bang all the way to building blocks for humans. Okay, so a brief history of time left unsaid. All observational evidence to date supports a picture of the universe that we just painted. But there's a number of questions that are left unanswered. Why was our early universe so hot? We don't know. Why is the universe so uniform on a large scale? Why does it look the same at all points? We don't know. Why did the universe start off with so nearly the critical rate of expansion and is still expanding at that rate? We don't know. Despite the fact the universe is so uniform, homogeneous, and there's local irregularities such as stars and differences in galaxies. These are thought to have developed from small differences in density. And why did these original fluctuations occur? We don't know. So there's a lot that scientists just don't know yet. And they get frustrated because they want to understand finite. Like they struggle with the concept of infinite. So Stephen Hawking does talk about God in A Brief History of Time, but like I said, he struggles with it. The general theory of relativity is what Einstein came up with, and he says the laws of science should be the same for all observers, no matter how they are moving. But the theory of relativity cannot explain the unanswered questions. So what Hawking does is he says we might as well cut out the Big Bang and the events before it out of the theory because they have no effect on the observational space-time. Basically what he's saying is this explanation of the universe has a boundary condition, and before that condition we just don't know. That's what they struggle with, but you'll see that. So Einstein said God, so they try to explain it with different weird models that just don't make sense, such as there's this chaotic model saying it just randomly happened. The universe was randomly created. Einstein laughed at that, said God does not play dice. That didn't mean that he was religious. I believe he was an atheist. That's what I read. But he believed in mathematical laws of nature, so his idea of God was that, at best, someone who formulated the laws and just left them alone. But we don't believe that, obviously, as Muslims. We have in the Holy Quran, we have several mentions of the sun, of the moon, stars, penetrating through the heavens. There's a lot in there. So I wanted to share one chapter, Ash-Shams, where it talks about purifying the soul. The one who purifies the soul succeeds, and the one who corrupts it fails. So some of the verses are, by the sun and his irradiation, by the moon when she followeth, by the day when it unfolded its light, by the night when it enshrouded, by the heaven as it is built, by the earth as it is expanded forth, by the soul as it is perfected. It's a beautiful chapter, and I took this out of a translation of a tafsir, so I'm not making this up. In verses 1 through 7, an appeal is made to the reflective faculty mankind has endowed with. Each one of these objects mentioned, if studied intelligently, is one of the manifestations of God's might and wisdom. None else besides him could ever have imagined to effect. The soul, one of the greatest mysteries of the universe, is one of the most invaluable gift granted exclusively to mankind. What the soul allows us to do is pass knowledge through time on to our kids and generations. It gives us the ability to think, to teach someone so they can learn and then pass that knowledge over time. I'm going to talk about this later, but technological advancements happen because we did make discoveries. 100 years ago, we started flying, but now there's thousands of airplanes in the air. So we have that human intellect that allows us to carry forward in time. That's what's given. That you can't explain that scientifically. That was given to us by Allah subhanahu wa ta'ala. So, okay. Let's go back to the science a little bit. Sorry if I've lost you at this moment. I'm going to just finish here real quickly. The equation of gravitational force is F equals G m times m r over r cubed. So if you have a system of particles here, so if you have a system of particles, let's say you have the sun, the earth, the moon. Each one of these is exhibiting a force on each other. It's making it attract. It's giving it an attraction the Earth is pulling at the moon pulls back, creates tides. So the Earth's pull on the moon causes it to orbit around it. Okay, so there is this equation for gravitational force. Now, Earth has an escape velocity, which is given by this equation, v equals the square root of gm over r, where m is the mass of the Earth and r is the distance between the object and Earth. So if a spacecraft is trying to escape, you just look at what the distance is from the center of the Earth to that object. The escape velocity is 11.2 kilometers per second. So how much thrust is required to escape the Earth's velocity? You need to go from 0 to 11.2 kilometers per second. The Earth's gravitational pull is 9.82 meters per second squared, which is called 1g. So if we all are on this Earth and we're exhibiting a force down, that's 1g. If we were to give a force back up 1g, we would hover on this Earth. So you have to escape the velocity, you have to now have more g's than the Earth is pulling you. Okay, so if you're aboard a rocket that thrusts at 2 g's, it would take about 19 minutes to escape the Earth. That's the math right there, you don't have to worry about it. So how much thrust would this kind of acceleration require? So F equals ma, that's Newton's first law. Let's say the mass of the spacecraft is 1,000 kilograms, and it's pushing down on the launch pad by 9.82 meters per second. So the mass of the spacecraft that's on the launch pad is pulling down, so you have to compensate for that weight too. So you're in there, and that spacecraft is weighing down. So now you have to have more G's to lift up. Be that as it may, the space shuttle required 12 million newtons of thrust to enter low Earth orbit. So what I'm trying to say here is it's a tremendous amount of energy to escape the Earth's gravitational pull. Okay, so just keep that in mind. Keep that in mind. Gravitational force, that's the equation. Earth's escape velocity, tremendous amount of energy to leave Earth. So now let's talk about the force within, which is the title of the presentation. As previously demonstrated, tremendous amount of energy is needed to leave Earth. As human beings, we contain atoms, so strong and weak nuclear forces, as well as electromagnetic force, are all a part of us. Remember the 4 fundamental forces. But here's a rhetorical question. Do gravitons reside within us? As the value of r sub ij, which is in this equation right here, decreases in the denominator, or increases, so that's a typo, sorry, increases in the denominator, the Earth's pull on that object is going to decrease. So think about it for a second. When the object is leaving Earth's orbit, the distance between that object and the Earth is increasing. The Earth is losing its pull. Now take all this physical, scientific example, adopt it to your life. Imagine I is you, J is corruption and sin on the Earth. The more you distance yourself from this corruption, the less attraction it will have on you. This requires a tremendous amount of energy on an individual, effort. On the other hand, imagine I is you and J is the Kaaba. How many of you have been to Hajj, just with a raise of hand, or Umrah? How many of you felt a force as you get closer to the Kaaba? So this is what I'm trying to talk about here is this equation is physical, but it also applies spiritually. Are there regions on the Earth where the pull of spiritual force is stronger than others? How many have been to Karbala here? How many of you have just sat in a majlis and felt that force? So I'm saying let's just conclude it. According to science, humans have only been on Earth for 190,000 years. The universe is 13.8 billion years old. The initial conditions of the universe needed to be perfect for the existence of life. If the critical temperature was a slightly different value, protons and neutrons wouldn't have been able to join together. And if you just walk down that explanation I gave you, there would be no life on Earth. So there's got to be somebody behind this. Like I said, just over 100 years ago, the first airplane flew. Now thousands of airplanes fly. So technological advancements are occurring. We haven't perfected anything yet. However, I believe they're not going to be able to answer why the universe was created. We know in the depths of our soul there's a force that exists that was created to submit ourselves to God because He created us. That ties it all together.